Hey, what do you see?
I see a web page titled PulseViz, Synthetic PPG Waveform Visualizer. It shows a graph of a wave pattern, along with several sliders for adjusting parameters like heart rate, oxygen saturation, waveform sharpness, noise level, and dicrotic notch intensity. There is also a description of the web application at the bottom.
Okay, what happened now? What have changed?
The value of dicrotic notch intensity was changed using the slider, and the graph was updated as a result. The dicrotic notch intensity value is currently 10.
Okay, and what does it do to the signal?
Slider for dicrotic notch intensity was moved, and its value changed from 10 to 0. As the value decreased, the small notch on the downward slope of the graph became less pronounced, until finally the graph looked like a smooth curve.
Okay, how about now? What's happening now?
The heart rate, BPM, slider was moved, which changed the displayed heart rate from 161 to 112. The wave graph also changed to reflect the adjusted heart rate, with the waves now occurring at a slower rate.
Okay, can you explain what's happening now?
The noise level slider was moved, and its value changed from 2 to 10. This caused the waveform graph to become more jagged and irregular, introducing more visual noise into the signal.
Okay, how about the oxygen saturation? Is it behaving correctly, or is anything else meant to be changing on the signal as I move the oxygen saturation percentage up and down?
The oxygen saturation percent slider was moved. It changed the value from 91% down to 85%, and then back up to 100%, and then finally down to 86% as the user manipulated the slider. This change does not appear to affect the waveform on the graph.
Okay, can you double check? I'll do it slowly, moving the oxygen saturation from 100 all the way down to 85. Can you actually see anything changing?
Okay, the oxygen saturation percent slider was moved slowly from 100% down to 85% and then back up to 98%. The graph did not change as the value was adjusted.
You didn't see any amplitude change to the signal. Can you double check?
The oxygen saturation percent slider was moved between 100% and 86%, but the wave signal did not change.
Okay, how about now when I move the wave sharpness? What's happening? Can you describe the waveform?
The waveform sharpness slider was moved between 5, 6, 4, 8, 4, and 7, and then back to 3, and then finally 5. This changed the sharpness of the wave's peaks and valleys, making them more or less pointy.
Okay, can you tell me the difference in the waveform between waveform sharpness 5 and waveform sharpness 6? What's happening to the waveform on the chart?
When the waveform sharpness is 5, the peaks and valleys are less pointy, and when it's 6, they are more pointy.
Yeah, but was there anything else unusual about the waveform?
The oxygen saturation slider does not appear to be affecting the waveform. Also, the waveform is mostly consistent besides for changes in sharpness.
Can you look at the top, the peaks of the waveform? As I change the waveform sharpness from 7 to 6, what happening to the peak of the waveform?
When you change the waveform sharpness from 7 to 6, the peaks of the waveform become less pointy.
Do they behave in any unusual manner?
The oxygen saturation percentage slider does not change the waveform. Otherwise, the waveform changes in the expected way.
Now forget the oxygen saturation slider. We're talking about the waveform sharpness slider. It seems like there is something unusual happening to the waveform every second number. So with odd numbers, the waveforms seem to be correct, but with even numbers, the top of the waveform seem to collapse down. Do you see that? Yes, obviously. I had a feeling that something will go wrong. Yeah, when you start pushing it or something, I don't know, it seems probably just timed out. But then, well, it doesn't say timeout, it says something went wrong. But it really seems like it's doing it when you know, pushing it or asking the same question multiple times or something. It's giving you a bit of an attitude. Yeah, there is some bug to this thing. This one actually we can try and resolve to the default. It's the default. Pop the image. Then we have 6. Hey, can you describe the images and particularly what changed between them, focusing on the shape of the waveform, and do let me know if you see anything unusual. This will be for all. We timed out on O1. It's using Pillow library to analyze the image. They're talking about had an error. And let's try a different model. This would be O3 mini. Let's see if it can do a slightly better job. I don't know why it defaulted to opening it using Python. I thought it has some inbuilt capability. So it's reasoned for 12 seconds. It doesn't actually tell you what the reasoning was.
From a broad perspective, all 3 screenshots show a very similar synthetic PPG waveform with a main, systolic, peak and a smaller secondary, dicrotic, notch. The general signature of a typical PPG signal is there. A relatively fast rise, a peak, and then a descending slope that includes a slight notch before returning to baseline.
Okay. It's not
In the second screenshot, the peaks appear a bit more pronounced and narrow, suggesting an increase in sharpness relative to the first. In the first and third screenshots, the wave is a bit more rounded at the peak. This is most noticeable if you look at the top of the systolic peak. It's slightly flatter or broader in the first and third compared to the second.
Yeah, it's now we're getting somewhere.
The notch is visible in all 3 but seems slightly deeper, more distinct, in the first and third images. In the second image, the notch appears subtler, likely because of the increased sharpness or slightly reduced notch intensity setting.
There is a bug in the code, but yeah.
All 3 waveforms have some minor undulations on the descending slope, suggesting a low to moderate noise level. However, none of the waveforms show extreme jitter or large erratic fluctuations. The difference in noise level between the screenshots is not very dramatic. There are no huge spikes or breaks in the waveform. Overall, these waveforms look like standard synthetic PPG signals, with expected features, a main peak, a smaller secondary notch, and a consistent rhythm. The slight changes in sharpness and notch intensity from one screenshot to another are typical of a tool that lets you adjust waveform parameters, so there's nothing particularly unusual or concerning in these images. They all fall well within what one might see in a normal synthetic or lightly noisy PPG trace.
It's actually, now that I'm looking at it, it's okay between 1 and 2. Yeah, there's something weird happening.